saying dumb things under your breath. Why are you doing that? Because you're a hater?
No, because if I said them out loud, I think they would be criticized.
Ah!
So you have successfully put filters on them.
Well, okay. Maybe that's good. A little useful criticism can
I'm
be
just
helpful.
not happy.
Everybody needs a little humility in their life, don't they?
What are you trying to do, Helen?
I tried to open it. What
Well,
else do
you
you
opened
think?
the lid, not the entire top of the bottle.
What are you doing?
You opened it?
It's like already been opened.
I know. I just tried and closed it again.
What are you doing with your life, bruh?
I think she was turning.
Okay, let's start learning about circles. Yay, yay. It was not very tight. Because I'm a strong man or something. Okay. All right, let's talk about some vocab. Do I have a large circle in here? Give me a second. I need a bowl for this unit. You're the one who never fails. Okay. Vocab time. This is called a circle. Wow. No way. A circle is an ellipse with the foci shoved to the middle, but you don't have to care about that till next year. That, because I said so, is the center of the circle. Wow. Okay. A line segment, which is fully contained within a circle, has a special name. So something like this. Does anybody know, without cheating and looking in your book, what that's called? No, but that is a special segment. That is definitely not a tangent, but that's as good a guess as any. Tangent is one that just touches one place. This, a line segment that is contained within a circle, is called a chord. Now, there is a specialized chord that y'all know the name of. If I take a chord which crosses through the center of the circle, what is that called? The diameter. That's easy money. We are, by the way, in this unit back to like real geometry. So like it's not like unbelievably easy anymore like it was last time. So, screw back your thinking caps again, right? Chord that goes through the center of a circle is called a diameter. And if we take and we cut a diameter in half, it's called a radius. Easy money, right? These we all know, except the chord maybe, but that one's not too hard to remember, right? Don't ask me why it's called a chord, because I have no idea. So if I gave you some circles and I said, identify these things, you could do it, right? Right. I'm not even, so they give you a formula that I'm not even going to write down. In order to calculate the size of a radius, you divide the diameter by 2, right? Y'all know that, yes? That's something you've known for a while. So that's a thing, it's in the book. That is a thing that's true. That is technically like a theorem or something, but I'm not going to write it down, right?
Diameter divided by 2 is 3.
Yeah, because you've known that for a long time, theoretically. And if you haven't, welcome to junior high, I guess. We'll speed past junior high and head to high school. Great, great. Okay. So, this formula, because I know that your education may be a little bit piecemeal, some of you, most of you, all of you, who knows? Question mark? I don't know. If we want to find the distance around the circle, first of all, that has a special name. What is his special name? There. Wow, y'all sound so depressed about it. The circumference is the distance around a circle, right? Oh, this whole distance. How do we calculate circumference? Pi times the diameter, or if we want to use the radius instead, how do we write that formula? 2 pi r, right? 2 times pi times the radius. That's the formula for the circumference of a circle.
Wait, why would you do the top one?
If we were given the radius. You could still use the bottom one. But I like the top one better, personally, because then the area and the circumference formula are both in terms of radius, but you can use pi times d, it doesn't matter. Same difference. Because 2 times the radius equals the diameter, right? Easy money?
Money's never easy.
We should probably do an example from this lesson before we move on to the next lesson.
Whenever we're using pi, how far should we go? Just do whatever.
You have a button on your calculator that has pi, use that. Because then it gives you to a whole heap of decimal places. And actually, I pulled out a new rag. Where did it go? Oh, there it is.
How many numbers is pi? Is it like,
Infinite.
really?
It's an irrational number. It's a non-repeating, non-ending decimal.
How does the calculator even?
There's so much of it.
I suspect it does it with a formula. I suspect every time you push the pi button, it does a little math in the background. I suspect, that's my guess. Or they did that once and then stored that however long variable, or excuse me, that very, however long, not variable, but constant as a thing on the machine. So one of those two things is how it does it on the calculator. I don't know for sure. Because you can calculate pi to however many decimals you want using a sequence.
Isn't pi the number of diameters in the circumference?
So pi we can actually figure out from circumference, because that's actually how pi is determined. Which is why pi is a bad constant and tau is better, because we don't actually construct a circle using its diameter. We construct a circle using its radius, which is one more reason to use the other one. But pi is defined as the ratio of a circle's circumference to its diameter, which it turns out, rather coolly, is always a little more than 3 units, always, which is kind of crazy and kind of cool. But that's where pi comes from, and that's what it is. Tau, on the other hand, is circumference to radius, and it's a better circle constant. There is an entire book on it. Yeah, it's 6.2 8, etc. Yes. It's double pi. And it's a better circle constant for every formula. In fact, it's so much better that I can't remember the author's name, but this guy wrote an entire book called the Tau Manifesto explaining in no uncertain terms why tau is better. Let's do an example. We're going to do find the diameter and radius of a circle to the nearest hundredth if the circumference of a circle is 77.8 centimeters. Yeah.
How would you use tau to find the area because it's pi squared squared?
I don't have that formula memorized, but it's an even simpler formula. Almost all of them are simpler with using tau, including when you hit some of the crazy stuff like in calculus and whatever else. Tau is just better. Okay. So we're given the circumference, we're supposed to find the diameter and the radius. How do we do that? Yeah, so to find the diameter, we would put 77.8 into the formula and divide both sides by pi, and we end up with what?
24.76.
And it says to the nearest hundredth, so yes, 24.76 what? Centimeters. And that's the diameter. Great. To find the radius, what do we do now? Divide that by 2. And we end up with the radius is approximately equal to what? 12 point something.
12.38.
12.38. I agree. Make sense?
Why did you put the number on the other side?
What do you mean?
At the top, you put 77.8 equals pi.
Because we typically write the formula as circumference equals that, but you could do it you could like flip both of these sides and it'd be the same thing, right?
So you just divide pi.
Yeah, because this pi is multiplied times the d, so we're just dividing pi on both sides, right? And you hit divide by pi. And don't type 3.14. You have a pi button. Did everybody know where your pi button is? Did you find your pi button? There's a pi button. Use the pi button. So that later in other math classes you can not find the pi button and just leave pi in your answer. Like if this was in like pre-cal or something like that, I would write d equals 77.8 over pi centimeters and circle it and move on with my life. Oh, too high. Okay. First homework set. I know I just said this. We're getting back to real high school geometry, and this is gonna not be easy. Well, this first lesson's easy. I don't know if y'all caught on to that part, but this first lesson is easy, and it is review, just like what we've been doing. This first one is easy money. Little vocab, bunch of review. First homework set. Page 701. Numbers. Did that give us enough? Yeah. It even gives us one kind of tricky problem. Oh no. 2 through 8 evens. Actually gives us, yeah, I want to give you all that one too. So 2 through 8 evens. And 9. Okay. All right, moving on. Measuring angles and arcs. Lesson 2. Are we still recording? Yes. Keep being a little bit paranoid because a week or two ago it kept like just randomly quitting halfway in the middle. Are you lost? Unit 10, Lesson 2. Measuring angles and arcs. Okay. First thing, you could probably guess, even without cheating in your book. And that is sum of the central angles. Right? So if I have any number of angles, we'll do the example like they do in the book with 3, but it doesn't really matter how many there are. I have these, and I have angle 1, angle 2, angle 3. And if I want to find the sum of all of those angles, what is that going to equal? 360. Yeah. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360 degrees. Make sure you put degrees because it doesn't equal 360 radians, it equals 2 pi radians. It does make sense. Now for a little more vocab. So those are called angles, right? Angles cut arcs, right? So there are 2 arcs if we have a couple of radii on there, right? There is a little one and a big one. The little one is called a minor arc. So what do you think the other one is called? Major arc. Wow. It's amazing that English works. All right? The big one is called a major arc, right? There it is. This guy right here. That's a major arc. We measure arcs 2 different ways. We measure their linear length, which measure in centimeters, inches, et cetera, right? But we also measure them in degrees. To calculate the measure of a minor arc, let's see, we should give us some letters to talk about, right? This is point A, this is point B, this is point C. So the way we write it is the measure of angle X equals the measure of arc AB in this case. Well, yeah, let's actually do it yeah, that's probably better notation wise. Let's do what they did. The measure of angle ABC equals measure of arc AB, which equals X. Right? Now, you may have noticed a bit of something that we'll talk about in a second. So how would we calculate the major arc from this?
360
Yeah. Yeah.
And then if it's for the linear length, it would be the circumference minus the minor length.
Right. Yes. Yes. That's true enough. So the measure, we need another point, don't we? Yes. D. The measure of arc ADB. Which we would notate like that. So if it is a major arc, we need another point to be like, okay, it's this big one, not this little one, right? That equals 360 minus the measure of the little one, right? Arc AB, which equals 360 minus x.
So the arc just equals the angle.
The minor arc just is the same as the angle. It's the same degree measure as the angle, yes. Okay. Now, one more piece of vocabulary. What is a half circle called? Apparently only Reese paid attention in middle school. Or in, that actually, semicircle. What is a semicircle is called? That's probably like third grade.
Well, my middle school was the same.
Oh my gosh.
I went to public school and private school, and it was terrible.
You and these other two girls, good Lord. Good Lord, Linda.
Look, I'd love to have complaining rights.
I'd love to have you. You got to learn like Jacob does. You don't have those in here, at least not without some teasing rights to go along with it.
I love
Those.
having power rights.
Half a circle is called a semicircle.
The right to be traumatized. He's just like up and down.
What's the degree measure of a semicircle?
50%.
50% of 360, which is 180 degrees. Technically not false. Technically not incorrect. Easy money? Good. What about, oh, I'm not going to write this one down either, but I am going to talk about it slightly. So this, it would be arc 1, right? Or arc AB. I say I'm not going to write it down, but apparently I am going to write it down, right? If we want arc AC, we could add arc AB plus BC, right? Same as segment addition, same as angle addition, same as all of those, right? Yes? If we have two little ones inside a big one, add the two little ones, get the big one, right? We've been doing that. We've been doing basically that theorem, or postulate actually, for ages, right? Now, next thing. What do we want to find? Not the degree measure of the arc, but the length of the arc. We need a formula.
Do you find the circumference and then?
So that is one way to do it, but if you don't have all that information, it's proportional, which is what I'm going to give you. But yes, you could do exactly what you said,
And then use the degrees to make a fraction.
which I guess technically kind of is what I'm going to show you. I'm just going to show it to you with the formula. But yeah, the walking through step by step is where the formula comes from. So yeah, I mean pretty much, yes. Okay, define the arc length. Now this, I will throw this out there. This particular formula is quite useful once you get to physics. When you start talking about angular momentum and angular speed and all of those formulas, you will use this formula again in physics. The arc length, I'll write all this. So you can do it as a proportion. I'm just going to write it and then we'll label the variables. Yes? Yes. Or if we were to solve this for L, right? Multiply this on both sides, we would end up with L equals 2 pi rx over 360. They didn't write it that way in the book, but I like that way better because it's prettier. Okay? Where did the 2 pi, what is the 2 pi r? That's circumference, right? That's easy money. Yes, yes. So this is circumference. L is the arc length. What is X? The angle in degrees. Right?
I forgot. That's exciting. Yay, that's so much more awesome.
Okay, let's do an example with this, and then we'll learn the best thing ever. So it could be what?
No, it couldn't be.
I'll take your word for it.
Just use the curved ruler to measure.
That is a way to do it. Yeah, absolutely. And if I was,
Really?
yeah, of course. That
People was laughing at me.
no, that's not. That is absolutely a fine way. Now, it depends on what application you're doing the thing in, right? Or whether you have access to the thing or whatever else on whether that's practical to do or not, right? But yeah, of course, you could use, and like you could use the string method, right? If you're doing something in real life. Like if I want to find the circumference of this bowl, put a piece of string around it and then measure the string, right? Absolutely. That is a method you can use.
He was laughing at me.
But you can't do that with like the earth.
In our math book, it doesn't work either because
Why
the circle is
not?
this big
Just
around
get a
and
large
it says this
string,
is
put it
5
up
feet
there.
diameter.
Right. That's true enough. That's true enough. Yeah, that doesn't work yet because the book is going to, yeah, that's true. Although it is proportional because all circles are proportional. So, there it is. Let's do an example. We're going to find the arc length of, we're going to find ZY, apparently. Actually, let's do AB. Let's do one of those.
I wonder what it would be like to look at the Earth from space.
Well, there are pictures of that. So, Let's do this one. Let's do where we've got what appears to be a diameter. And then there's another radius right here. This is 80 degrees. And labels this as 14 meters, which means that this is definitely a diameter because it only gives us one measurement. This is O, this is A, this is B. And we are supposed to find the length of AB to the nearest something, nearest hundredth. So, what do we do?
We're going to do 14 times pi.
No, we're not going to do that.
We're not going to do 80 over 14 times.
Well, not if we use the formula like we wrote it.
So you want to do 7 times 2 times pi?
Yeah, and then you get 14 again. Okay, good job. We got 14 back. Okay, great. So yeah, so we're going to do the length. So the measure of AB, arc AB, equals 14 pi. Excuse me, not equals, over 14 pi equals 80 degrees over 360 degrees, right? Oh, that's 9, isn't it?
Times 4 is
32, isn't it? Well, there you go. 8 and 36 still. So then we cross multiply. We get
Maybe 1 to 4
Instead of like,
what?
why is it not 28?
Why is your hood on your head? You look like a goober.
Why is it like that? Instead of what?
14 is the diameter.
But,
You
Okay.
could do 1 to 4 and a half. That's 8, 36.
You could, if you wanted to. Equals. What's 8 times 14? Y'all have calculators!
112.
Thank you.
My God.
Shouldn't take an hour and a half to when I say what is 8 times 14?
I didn't even hear you.
Well, then you have ears!
Well, I do now.
So you didn't 10 seconds ago?
No. They just grew it.
They spawned in. So the measure of arc AB is approximately equal to what?
Well, you see,
351.9.
That's definitely not what the book says, but
9.77.
Oh wait, we gotta do it divided by 36.
yes, sir, we do. 9.77 meters is what it says. Meters is what that says. Great. All right, so you know about degrees, right? There's 360 degrees in a circle, but you don't yet know about radians. Radians are another unit to measure angles, and they are way better than degrees. They're so awesome.
so what?
Awesome. Because radians are a ratio. Radian, and the other super nice thing about radians is when you get to trigonometry, it makes life so much easier. I know we've already covered some trigonometry in here, but y'all remember those like special angles and stuff and whatever else? Like when you do trigonometry later, you'll learn that if we have this angle and the same angle over here and the same angle over here, and if the reference angle is all the same, then the sine, cosine, and tangent is always the same. The SIGN might be different, but the sine of this is the same as the sine of this is the same as et cetera, right? To figure out what these angles are in radians, you just look at the denominator. Pi over 3 is the same as 5 pi over 3 is the same as 7 pi over 3, et cetera, et cetera, et cetera. So if it's pi over 3, then it's always going to go back to that one. It's great. Radians are awesome.
Doesn't matter what the top is.
Well, it does because that tells you what quadrant it is. So the SIGN might be different, but the number will be the same. But you'll see that later in pre-cal, if you take pre-cal, which you should because pre-cal is great. All right, so this circle is centered on these axes. I know it doesn't look like it, but it is. Don't give me that look. It is centered on these axes. All right, so radians are also given in terms of pi, which is great. Let's label some things. We've got arc length L right here, which we've used. This angle in radians, we use this symbol for radians typically. Actually, I use it just as angle, but this is a Greek letter theta. And it is an angle in radians. Okay, so that's what this is. This from here to here is r, right? What does r stand for? What has r stood for? Radius, that's true. Radians are defined as the arc length divided by the radius. Let's do it an example. Arc length is a linear measurement. Well, that's this entire unit, so strap in, girl. Bring a quarter or something. Use the bottom of your bottle isn't even round. I guess the bottom is. The bottom's probably round. So there you go. Now you got a circle. Look at that. You could use the lid, but you'd have to be able to get it off.
I did.
Nice. You didn't earlier. You were like, could you open this, please?
Yeah, I didn't earlier, but.
And I was like, ugh. And then I was like, oh, wait, this was easy. And so I decided to be like, okay. Oh my gosh, kids. That was some pretty good, like, vocal comedy. You gotta admit.
I don't get any break from bullying.
It's not bullying.
To laugh at my joke is bullying? Is that what you're implying? That doesn't make any sense. That doesn't even make any sense. Do you understand what the word bullying means?
Yeah. Every time I was
So it would be, just throwing this out there, it would be virtually impossible for you to bully me. Because in order for something to be bullying, there has to be a power difference. And the power difference definitely does not go in that direction in this scenario. I could bully you. In fact, I often do. But you couldn't bully me. You could be rude to me.
Yeah.
You could make fun of me. You could hurt my feelings, but you could not bully me.
I guess so, yeah. That makes sense.
Whenever you see families where the child can bully their parents, we got a problem that exists way too often. That absolutely happens. Okay, we are supposed to find the arc length find the length of the minor arc. Let's find the measure of arc ZY. Round to the nearest hundredth if necessary. So, how do we do that?
What is 7 pi over 12?
That's the angle in radians. Radians will almost always have a pi shoved in it. That's an O. I don't know why they're using O as the middle. Probably origin, I guess, is probably why they picked O, but it's an obnoxious letter.
Times 2, and that gives us 7.
What?
We're going to multiply 7 pi over 12 times.
We are. We're going to just shove it over here. We're going to do 7 pi over 12 equals the arc length divided by 2. So multiply 2 on both sides. So the arc length in terms of pi is 7 pi over 6 centimeters. But it says to round to the nearest hundredth, so we're going to shove that in our calculator, and we're going to get a number. It's going to be
3.67.
yeah. 3.67 centimeters.
What formula is that?
This one. The radians equals the arc length divided by the radius, which is kind of awesome. Radians are awesome. This is not in the unit, but just, well, no, I won't waste their time. I won't waste my time. Okay. Second homework set.
On the first homework set, number 9, were you wanting us to give it to you with the square root or as a decimal?
The key leaves the square root in there, but I don't care.
Okay.
I don't care which you choose. I think the key does. Let me look. Yeah, the key leaves pi and the square root in there.
Alright,
Oh yeah, yeah, and actually no, I do care because it says find the exact. So yeah, you would not multiply. You would leave pi. You would leave the square root. All those things. That's absolutely right.
yeah, I didn't know the exact meant you wanted it to
That's
be,
what-
like write out every single.
Yeah, that would be impossible because there are infinite of them. But yeah, exact means leave the pi and the square root in there. Yep. Great question. All right, so pages 710 through 711, but not the convenience store. Numbers 14 through 42 evens. You can either leave early or get started on that extra long homework set now. I don't care which. You've got 7 minutes.
Question. What are all the answers?
I only answer questions that would be helpful to you.
That is helpful.
No, it isn't actually. Because your goal is to learn the math, not